Hi there! In this video, we will tackle the procedure in conducting mortar mix concrete. Before conducting the activity, the team agreed to have water cement ratios as 0.45, 0.55, and 0.65 for the three mortar samples. Meanwhile, ratio for the dry aggregates was 1 kg of cement is to 2 kg of fine aggregates is to 3 kg of coarse aggregates. Materials used in the activity include 1P Portland cement, fine aggregates, coarse aggregates, measuring pan, weighing scale, shovels, trowel, water, cylinder for measuring water, mixing pan, cylindrical mold, tamping rod, and compression machine. Fine aggregates and coarse aggregates were sun-dried to lessen the moisture content. Using a measuring pan, 6 kg of fine aggregates and 9 kg of coarse aggregates were weighed and mixed on the mixing pan. The aggregates were mixed thoroughly and evenly. Then, 3 kg of Portland cement was weighed and mixed with the fine and coarse aggregates on the mixing pan. After ensuring that the dry aggregates were mixed evenly, 1.35 liters of water were added and mixed continuously. By using a cylindrical mold, the mortar mixture was placed 1/3 of the full capacity of the mold and tamped 25 times. Another 1/3 was again filled and tamped 25 times using a tamping rod. Then, the cylinder was filled fully and still tamped 25 times. The surface was then smoothed using a trowel. The sample was then placed in an area away from possible disturbances and direct sunlight. Same procedure was done for the samples with the ratios 0.55 and 0.65. However, the amount of water was 1.65 liters and 1.95 liters respectively. Samples were labeled 0.45, 0.55, and 0.65 for easy identification. After 24 hours, samples were removed from the molds and cured for 5 days. On the 6th day, samples were removed from the curing tank and set aside for 1 day. After a day, samples were subjected to compression test using compression machine. Sample of water cement ratio 0.45 had a maximum strength of 23.693 megapascal with a maximum load of 447.070 kilonewton. Meanwhile, 0.55 water cement ratio gained a maximum strength of 20.548 megapascal and a maximum load of 387.730 kilonewton. And 0.65 sample had a maximum strength of 14.230 megapascal and a maximum load of 268.517 kilonewton. In conducting this activity, the team learned the proper laboratory test procedure of mortar concrete mixtures. The team also learned that less water produces weaker concrete so as to mixtures with so much water. A balanced water cement ratio gives off stronger concrete. However, ratio of concrete mixture also depends on to where the concrete will be used, be it as a filling for footing, beams, columns, walls, or any other else. We also learned to classify the types of stresses present in the concrete samples when undergone compression. After conducting the activity, the team would like to know more about the best concrete ratio to every usage of the concrete. The team are also looking forward to knowing what the adjustments in the concrete mixture that will be followed by the engineers in other countries considering the weather they have at their place. Now that we already know the appropriate procedure in conducting the concrete test, this knowledge will be used when we will be working at the laboratory soon.